Hello, everyone. Mr. Minnick's my name. Math is my game. And this is the third and final installment here of our set of notes on fractions in this Algebra 2 class. I hope that today is a good day for you. Here at school this week, we have a nice short 4-day week. I'm so stoked. It's NEOEA Day on Friday. For those of you wondering what that means, it's Northeast Ohio Educators Association Day. In other words, anybody that lives in Northeast Ohio, any teacher that lives in Northeast Ohio, is supposed to go and become educated to be a better educator. But I'm going to sleep in on Friday. I'm not going to lie. So I just put that out there. Okay. So before we talk about multiplying fractions, what I'd like to talk about are two phenomenons that people often confuse. And I don't know if that should have one L or two. So if it's supposed to have two L's, I'm sorry. But cross-canceling, as opposed to or juxtaposed with cross-multiplying. Those two ideas, a lot of people, I think, sometimes confuse them. And when we're multiplying and dividing fractions, cross-canceling comes up, cross-multiplying should not. There's a nasty shortcut that some people have shown students when it comes to dividing fractions, and they actually do this cross-multiplying, and I don't like the shortcut. I'll show you what it is and why it's bad. But anyway, so cross-multiplying, the deal with cross-multiplying, this is used for the sole purpose of solving a special kind of problem. Anybody know what kind of problem it's used to solve? It starts with a P and has another P in it and ends with an N. It's 3 syllables. What kind of problem do you use cross-multiplying to solve? Back in the day in business and economics, it's called the rule of 3. If you know 3 parts, you can find the 4th. X is to 7, as 28 is to 56. What's that called? Starts with a P, has another P in it, ends with an N. Cross-multiplying is used to solve one of these. 7 times 28, oh man, that ends in a 6, right? And I got to carry my 5, so it's 196. So X would equal whatever 28 divided by 8 is. It's 14 fourths. That's 7 halves, I think. You know what this is called? Really? Somebody's got to know. 3 syllables. Okay, well. Anyway, it's used for solving those problems. Used for solving those problems. All right. Cross-canceling. Cross-canceling makes multiplying fractions not just a little bit easier, not a lot easier, but way easier. Cross-canceling makes multiplying fractions way easier. And it's a skill, it's an art, it's something that I think wasn't gone over enough in 6th grade. Wasn't gone over at all in 7th grade. Somebody just handed you a TI-30X2S and said, here, there's an ABC button. Use it, because I don't want to go over this stuff with you anymore. So cross-canceling is something that makes multiplying fractions way easier. Just for completion's sake, I probably ought to finish up that last problem that I was trying to solve. How many times does 56 go into 196? Is it 3? Is that 3? So that's an 8, carry the 1. That's a 16. So that's a 16, that's an 8. And that's going to be an 8, so that's a 2, so that's 28. Yeah, 3.5, 7 halves, like I said. Yeah. So x is 7 halves, or 3.5. Just so you know, that was a portion. I know it's been a while. I know the vocabulary sometimes escapes us. But cross-multiplying is used for solving proportions. Cross-canceling is something that I really want you to be able to do. Okay? So let's take a look at cross-canceling. Numerators, regardless of their location, as long as they're numerators, regardless of whether they're on the right, in the middle, on the left, numerators, regardless of their location, cancel denominators. And I could say the same thing about denominators. Denominators, regardless of their location, cancel numerators. When I say regardless of their location, because I'm saying denominators, it's clear, it's implied that they're still in the bottom. But what I'm saying is they could be on the right, on the left, somewhere in the middle, somewhere near the left. What I need to make clear here is numerators do not cancel numerators. And finally, denominators do not cancel denominators. Denominators do not cancel denominators. So this cross-canceling, it's going to make multiplying fractions way easier. So numerators, regardless of their location, cancel denominators. Denominators, regardless of their location, cancel the numerators. Numerators do not cancel numerators, and denominators do not cancel denominators. Some of this stuff might seem like common sense, but it's worth noting, because when we get to chapter 8, people start to make up their own rules about these kind of things. Anybody in here ever take a physics class? I want to thank my physics teacher. I'm going to give a shout out to Mr. Powell. Mr. Powell was a very trim man, about late 50s, early 60s, always drank tea. Always. He was about 5'10". I learned more math in physics than I ever did in math. I learned more fraction analysis in physics than I ever did in a math class. Okay, so let's take a look at this cross-canceling business and see what it's all about. 6 divided by 8. Would everybody agree that 6 and 8 will cancel one another? Would everybody agree to that? They won't cancel each other completely out, but let's think about 6. 6 is really 2 times 3, right? You picking up what I'm putting down here? And 8 is really 2 times 2 times 2, if I break it up into its prime factors. You with me so far? So what ends up happening with this 2 and this 2? Those 2's cancel each other out, right? What do they turn into when they cancel each other out? They turn into something. It's nothing that shows up. It's 1. Some people think they turn into a 0. It actually turns into a 1, and when we're multiplying, 1 is irrelevant because it's the identity. But 1 is still something. So they turn into 1s. Okay? So if we look at what's left over then, if we look at what's left over, up top is a 3, and in the bottom is 2 times 2, which is 4. Now, some of you right from the beginning might have looked at this and said, okay, so the 6 and the 8 are both divisible by 2. So the 6 becomes a 3, and the 8 becomes a 4. So that's what canceling is. Okay? That's just plain canceling. That's just plain canceling. And again, if there's two L's, I'm sorry. I don't know if it's one or two. I should probably look that up. Is it two L's? Thank you. You sure about that? Let's go to the boss. I want to go to Microsoft Word. I'm not saying you're wrong. Not saying you're wrong. You're probably right. I'm probably wrong. Microsoft Word, something that some of you might not have used in years, huh? Do I even have Word on this calculator? Computer, thank you. Good looking out. Do I have Word? There's Word on this. I said calculator. That's a neck. I just necked myself. All right. Canceling. Whoop, canceling. 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 Whoop. Canceling. Canceling. Okay. Spell check. How do I spell check? How do I spell check? Tools? Where's the tools at? Review. There we go. Review. Spelling. Wow. They didn't say either of them's wrong. Maybe we'll have to go to Goggle later and get clarification. Maybe we'll go to Goggle now. We'll go to Goggle now. Canceling or canceling? Here we go. English Stack Exchange questions. I'm hearing two L's. Maybe it does. I don't know. That'd be a good question for your English teacher. Ask your English teachers and get back to me. Canceling or canceling? All right. Well, we've wasted enough time on that. So let's look at cross-canceling then. Here we go. So suppose we had a big fraction. Suppose we had a really big fraction. When I say big fraction, I mean huge fraction, right? Suppose we have 15 times 16 times 17 times 32 times 4 times 5 times 300 all over. Let's make this a 25 here. And let's make this a 48 here. And let's make this 150 here. And let's make this a 60 here. And let's make this a 51 here. And let's make this a 64 here. Okay. So the chances of you running into a fraction like that, probably very slim. But I want to show you how cross-canceling works, okay? So when you multiply a fraction, whenever you multiply a fraction, where did that page go, multiplying fractions? When you multiply fractions, you don't need common denominators, first of all. Did you know that? Some people think you need a common denominator. You don't. It's just numerator times numerator, denominator times denominator. That's all you got to do when you multiply fractions. Just multiply right across the top and multiply right across the bottom. Pretty easy to do. It's actually easier than adding and subtracting. Did you know that? But it's way easier if you could cross-cancel. So this example, oh my. Nothing this morning is working the way I was hoping it would. So I'm going to have to multiply 15 by 16 by 17 by 32 by 4 by 5 by 300. How big of a number do you think that's going to be? I think it's going to be something in the billions. Maybe I'm wrong. There's 3 zeros, 360. It's 783 million. That's a big number. Anyway, the denominator would be 25 times 25 times 48 times 150 times 60 times 51 times 64 the denominator would be something in the tens of billions. So 783 million divided by 3.5, or divided by 35 billion. Could you imagine trying to reduce that down? What does your 6th grade teacher say when you reduce? If they're even, divide by 2, right? So the whole point I want to make is if you cross cancel, hopefully that calculator stays there and I don't exit out of that. If you can cross cancel, you can make this problem so much easier. So much easier. So what I'm doing is I'm looking at things. I'm looking at this 15, and I'm trying to scan the denominator. I'm trying to scan the denominator and see if there's anything in the denominator that I can cross-cancel here. Anything that shares a factor in common with 15, and there's actually lots of things that do. Who can point out one thing that I should probably cancel the 15 with? What do we got? You could cancel it with the 25. I'd probably pick something else. What are you thinking? I'm hearing 150. You could cancel it with 150, but I'm thinking something else. 60. I like the 60. Does it matter which one you use? No. It doesn't matter which one you use. Let me go ahead and just take this page, and I'm going to duplicate this page. And hopefully we have enough time to do a couple of these. Okay, but I would cross-cancel the 15 with the 60. So the 15, I'm going to do a strike-through through it. The 60, I'm going to do a strike-through through it. What's my 15 going to turn into? A 1. And what's my 60 going to turn into? A 4. And what's the magical tractor turn into? The magical tractor turns into a field. All right. The 1 has nothing that it can cancel with, right? So we've successfully taken care of that. Now, let's move on. Do you see this 4 over here? Do you see this 4 down here? But wait, you can't cancel something that already canceled with something else. Yeah, you can. Did you know that? So the 4s now can cancel. So this 4 becomes a 1, and this 4 down here becomes a 1. Wow. Huh. So whenever you're canceling or cross-canceling, it's a good idea to have a different colored writing instrument. Don't have to, but or just get creative with the marker or pen strokes that you use. So I'm going to go to the 16. Who can read my mind and say what I would like to cancel the 16 with? The 48? 48's not a bad one. What else would be a 64 would be a good one too. Either one, take your pick. I'd probably go with the 48. And the reason for that is later on I'm going to do the 32 with the 64. You're picking up what I'm putting down. All right. So the 16 is going to turn into a 1. The 48 is going to turn into a 3. Do you notice how I'm using similar strike-throughs on the ones that I'm canceling with each other? Okay. Not a bad practice to do. You don't have to do that, but it's not a bad practice. All right, so the first 2 terms are completely gone. Rather than having something that's 783 million over 35 billion, now I just eliminated the whole first 2 terms. I'm going to skip over the 17 for a minute. Let's go to the 32. We said we could do the 32 and the 64, right? Okay. So the 32 is going to be a 1, and the 64 is going to be a 2. What do you think of this cross-canceling? Does it make sense, the idea? It's going to make this so much easier. So much easier. Okay. So the 5 up top, is there anything in the bottom that the 5 can cancel with? 25. Cool. Awesome. So we're starting to get the hang of this. So this 5 is going to become a 1. The 25 is going to become a 5. Good. And up top, there's only 2 things left. This 300, can we cross-cancel the 300 with anything? 150, okay, so the 300 is going to become a 2, and the 150 becomes a 1. Wow. Dude, we just made this from something in the millions over something in the billions to, look at all that's left up top. The only thing that's left up top is a 17. It'd be nice if we could cross-cancel that with something. Oh, okay, so the 17 then is a 1, the 51 is a 3. Now, all that's left up top is a 2. There can't be anything in the bottom that could cross-cancel with that 2, is there? Oh my gosh, there's a 2 in the, so we could cancel this 2 with this 2, and that's a 1, and that's a 1. So that whole big problem that was 783 million over 35 billion ends up being 1 times 1 times 1 times 1 times 1 times 1, which is 1, divided by 5 times 3 times 1 times 1 times 3 times 1, which is, what is it? 45. Cross-canceling makes multiplying fractions way easier. Learn to do it. So there's really only one last thing we got to talk about then, and that's dividing fractions. Dividing fractions. When you divide fractions, you don't mess with the first one. And then you take the second one and you flip it, and then you multiply. And I have a nice little cool picture of somebody backflipping a snowmobile. I'd like to backflip a snowmobile one day. So when you divide fractions, you leave the first one alone, you flip the second one, and you multiply. So let's look at 3/8 divided by 4/5. What do we do with the first fraction? Leave it alone. And what do we do with the second fraction? Flip it, so that's going to be 5/4. And then we turn this dividing into multiplying. And so this is what we're looking at. We're trying to multiply these. Can we cross-cancel anything? Numerators cancel numerators. Denominators cancel denominators. Can we cross-cancel anything? The 8 and 4, well, denominators don't cross-cancel, don't cancel denominators. So we can't really cross-cancel anything, can we? So what's our answer? 15/32. What do you think? Do we need to see an example of just straight up multiplying fractions, or you got it? Okay, that's it. It's been real. It's been fun. We'll talk about all the other loose ends in class when we go over the exercises. Have a nice day. Shout out to the future Mr. Minnick. Good.